right, so let's take a look again at this problem that we had. So we had a function, x squared plus x minus 6. So f of x was x squared plus x minus 6. And we were able to graph it. We had a table of values with x and f of x. We also found a situation where the value of that function was 0. So we said, all right, well, we can actually find when that equals 0. Okay, so find values of x. Okay, and then we also took this and we rewrote that as a factored form. Now, each one of these arrows can actually be bidirectional. So, x minus 2 can be bidirectional. So we can go from both from the equation, so from the function to the graph, but also from the graph to the function. We can, using the graph, we can figure out what the function was. Using the table of values, we can also figure out what the function was. We can go from the graph to the table of values and back as well. If we have a factored form, we can create a standard form. Okay, this is called standard form. Now, this equation though, now if we have this equation, the x squared plus x minus 6 equals 0, we can also go back to the function, right? Do you see that all it's done is it said, this equation says that the function, the value of the function is 0. And if you know the value of the function is 0, then you should be able to figure out where the x-intercepts are, or what the factored form was going to be. So in fact, you can go in each direction from this equation as well as from the function. Now what we're going to call this equation, the associated equation. Okay, the associated equation where the function equals 0. So let's take a look at some situations where you're actually given the associated equation and you want to find a function, that associated function, which will help us find the value of the x's that the equation is looking for. So for example, with x squared plus 3x, I'm going to write it out here, we're looking for equals to 0, and we know that if we had a function that equals 0, we'd be able to either graph it or table of values and find out when that function equals to 0, or factor, right? So that is actually how we're going to look at it. We're going to say that what we're looking at is this associated function, and when the value of that associated function equal to 0. So when the value of x squared plus 3x is equal to 0. So really what that question is saying is, let's take a look at this value of this function and check out when it's equal to 0. So I'm going to pause here because I'm going to use some technology to create the graph and use some technology to create the table of values. And then I'll come back to insert both of those in here, and then we'll factor together. So now we see that I've gone and I've created a graph of x squared plus 3x. I've also created a table of values for x squared plus 3x. And on the graph and on the table of values, we can already identify where the whole function, the value is equal to 0. Table of values and the graph. So both of those would tell us that when x is negative 3 or x is 0, the value of the function is 0. However, so we've done it, we've looked at it through the graph, we looked at it through the value table of values, but we should also be able to factor it. If we're going to factor it, And this is going to be as if we have algeblocks. So I'm going to factor this as my x squared, and 3x, I'm going to create a rectangle. Right, so the factors for this function are going to be x on the vertical and x plus 3 on the horizontal equals 0. And you notice that when 0 times anything is 0, so when x equal to 0, or when this equals 0, or x equals minus 3, then the whole value of the function is going to be 0. So we found these values using 3 different ways, 3 different methods. And sometimes, honestly, the table of values seems to, unless you have technology really at hand, doesn't seem to really be that useful. The graph is very visual. It's a nice way to represent the solutions, and the factored form is a very nice format as well. So try to do that for B, C, and D, and we'll come back to look at E together. Okay, so let's look at question E. X squared plus 3x equals 10. Now, it may be familiar. This function may look very familiar to you. So, because that's actually the function we were looking at in question A. But in this case, what we're looking for is when is that value, the value of that function, equal to 10. So somewhere up above and beyond the graph, but somewhere in here, we're going to have to figure out when that x squared plus 3x, the value of that is equal to 10. So it's not trivial to be able to do that. There's not really a good, I mean, if you had a graph or if you had a table of values, you certainly could solve that and do that by examination. But the factor method is not going to work, because if you factor it the same way that you did before, then there's no way to really figure out what the value of x is. It's just by trial and error. I mean, you could say that, oh, it's 10. What multiplies to 10? 2 and 5. All right, so maybe if x is 2, then 2 times 2 plus 3, 5 equals 10. Yes, but what's the second answer? What is that negative answer? That's going to be really difficult to find. So although that method is theoretically possible, what we can do is we can find a different associated function. So what if we rewrite this into an equation that equals 0, where we're actually looking at a more complicated function, true, but it's in a situation where it's equal to 0 and we know exactly how to find those points. So what if we write an associated function, which is x squared plus 3x minus 10? So then if we graph that and find the table of values, then we should be able to do, and factor it, we should be able to find a much easier path towards our solution. So I'm going to go away again, and I'm going to come back with a graph, and I'll skip the table of values if that is okay with you. I think we know what that would look like, but we will do the factoring together. All right, so here's the graph, and we can see that, yeah, there's that 2 that we were looking at before. All right, so at 2, it does in fact cross the x-axis, and there's another x-intercept over there somewhere with -4, -5. So that may be a hint, so we can test if -5 gives us the answer, the 0 value. But we could also look at it as in terms of algeblocks and see if we could factor this equation to give us a different form that might be easier to solve for when it equals 0. So we have x squared and 3x and minus 10. So the minus 10 are likely to be in here, and they could either be as 2 by 5 or 5 by 2. Well, the 3x, if we put in here already, there on the positive side, then it would make sense, and you can use the algeblocks themselves, to say that the 1's would go like this, 5 by 2. Because what happens here is we have a gap left where we can insert 2 0 pairs. 2 0 pairs. All right. So now what's happened is we now have a rectangle, and our f of x is equal to the vertical factor is x plus 5, and the horizontal factor is x minus 2. And that whole thing equals 0. Well, in this case, we do know how to find the value that make the function equal to 0. Well, either if x plus 5 is 0, then 0 times anything is 0. So there's the x minus 5. Or if x minus 2 is 0, then anything times 0 is 0. So we have our two solutions. We have our two solutions, and in fact, we've confirmed that that is x equals negative 5. So I'm going to let you work on F, G, and H, and we'll come back to do I together. So I'm assuming that you've taken a look at F, G, and H, and with the I together, let's see what we can do with the graph and the associated equation. So the associated equation, or function, if we take this, then we're going to be looking for a value of the function equaling 3. Not always an easy solution. But if we take an associated function to be x squared plus 5x minus 3, and we're looking for that to be 0, then we have a good plan of how that's going to happen. First, we're going to graph it and see when the function crosses the x-axis, and secondly, we're going to factor it and see if we can find a factored form. In fact, let's do that first, and then we'll check with a graph. So x squared, we have 4x, 5x, and we have the minus 3. That's what we have. In order to make that into a rectangle, we need to find another 0 pair of x. And then we can read off that f of x is x minus 1, x plus 3. 2x minus 1, pardon me, 2x minus 1, x plus 3. And we want for that to be equal to 0. So either the 2x minus 1 is 0, or x plus 3 is 0, because 0 times anything is 0, and anything times 0 is 0. So x is 1/2, or x is minus 3. Okay, let's see if we can do the same thing with a graph. We can confirm this with a graph. And here we have the graph. And I think we should be able to see that x equals 1/2 and x equals minus 3 do align with the places where the graph crosses the x-axis. So we did confirm it with the graph. I'm going to let you pause and head back to J and K, and then let's take a look at I. So if we have 9x squared equals 1, we could say that this is our associated function, but that would be a little bit more challenging than saying f of x equals 9x squared minus 1 is the associated function, and we're looking for when that equals 0. So again, we're going to do the factoring first, and then we will find the graph. So if we have 9x squared, then the possible rectangles are either 3 by 3 or 1 by 9. 1 by 9 is going to be super long and probably will not be very helpful. So based kind of on our experience from the past. So why don't we start with a 3 by 3 x squared, 9x squared, and minus 1. Minus 1 in one of the kitty corners. So then we would need to use our 0 pairs to fill in minus 3x and the plus 3x. All right, so there's the minus and the plus. So we're able to rewrite this as 3x minus 1 and 3x plus 1. So if that's equal to 0, then we should have either one of those being set to 0. We'll make the whole equation 0, the whole function value 0. So either 3x minus 1 equals 0 or 3x plus 1 equals 0. So either x is 1/3 or x is minus 1/3. So let's see if we can find a graph for this, or make a graph for this, and figure out how we did. I'll be back. And here we are. We have the graph, and the x-axis intersects with a function at about 1/3 and negative 1/3. Obviously the graph would not be the ideal method here, because it's hard, at least this graph it wouldn't be, because it's hard to confirm that that's actually 1/3 and negative 1/3, but it confirms our other calculations. So make sure that you can go through the rest of the problems and be able to use technology to graph it, whatever the technology is. You might use your calculator, or just type in the function into Google and it should graph it as well. And also by factoring, right? By finding the associated function that's equal to 0 and by factoring it. And then we'll be back to how to go through a couple of examples of problem situations where this would be a handy method to